Hi to all. Today we are going to discuss about the topic of random variable. First, what is random variable? A random variable is a real valued function whose domain is the sample space of a random experiment taking values on the real line R. There is two types of random variables there. One is discrete random variable and another one is a continuous random variable. First, what is discrete random variable? A discrete random variable is one which can take only finite or countable number of values with definite probabilities associated with each of one of them. That is discrete random variable. The next is continuous random variable. What is continuous random variable? A continuous random variable is one which can assume every value between two specified values with a definite probability associated with each. Generally, the discrete random variable is a probability mass function, and continuous random variable is probability density function. What is probability mass function is let x be a discrete random variable which assuming the values x1 up to xn with each of the values with associated number of called the probability, that is p of x is equal to xi is equal to p of xi where I tends to 1 up to n. This is called the probability of xi satisfying the following condition. One is the probability values lies in between 0 to 1 and total probability value is 1. Similarly, the probability density function is a function f is said to be a probability density function of a continuous random variable x if it satisfies the following properties. That similar one, that is f of x is greater than 0, that is the interval is minus infinity to infinity and total probability value is equal to 1. Next, we move on to the distributive function or cumulative distribution function. In discrete variable, a distribution function of a discrete random variable x is defined as the probability of x less than or equal to x, the summation p of xi. Similarly, in continuous case, a distribution function of a continuous random variable x is defined as f of x is equal to p of x less than x is equal to integral minus infinity to x f of x dx. We describe the discrete case is summation and continuous case is integral. Next, we move on to the mathematical expectation. The expected value of a random variable x is defined as the x is a discrete random variable, then expectation of x is equal to summation xi p of xi, where p of x is the probability function of x. Similarly, in continuous random variable, expectation of x is equal to integral minus infinity to infinity x into f of x into dx, where f of x is the probability density function of x. Next, we're going to see the properties of expectation. The property number 1 is if C is a constant, then expectation of constant is equal to constant. We no need the proof. We just see the properties. The second property says if A comma B are constants, then expectation of AX plus B is equal to A into expectation of X plus B. Similarly, properties 3 is if A and B are constant, then variance of AX plus B is equal to A square variance of X. And property number 4 is if A is a constant, then variance of AX is equal to A square into variance of X. In property number 5 is variance of x is equal to E of x square minus the expectation of x whole square. Next, we are going to see the moment generating function. We generally see that is MGF. A moment generating function of a random variable x is defined as mx of t is equal to expectation of e power tx is equal to, the first case is the continuous case and second case is the discrete case. In first case is the continuous case is generally we define as integral, and discrete case we generally define as a summation. Next, we are going to see the problems. The problem number 1, if the probability distributive function x is given as where x is equal to the values 1, 2, 3, 4, and probability of x is equal to 0.4, 0.3, 0.2, and 0.1. Here, find probability of 1 by 2 less than x less than 7 by 2 is given x greater than 1. Here, probability of 1 by 2 less than x less than 7 by 2, it's a intersection and x greater than 1 divided by probability of x greater than 1. And what is the value in between 1 by 2 and 7 by 2 is here 2 and 3. And similarly, probability of x greater than 1, obviously the values are 2, 3, and 4. We are taking the corresponding 2, 3, and 4 values. That is probability of x is equal to 2 and probability of x is equal to 3 by probability of x is equal to plus 3 plus 4. We're taking probability value and x is equal to that corresponding value is 0.3. And probability of x is equal to 3 and that is corresponding value is 0.2. Similarly, the probability of 2, 3, and 4 that the value is 0.3 plus 0.2 plus 0.1. We will get the value that is final answer is 5 by 6. Similarly, we are taking problem number 2. The problem is a random variable x as the following probability distribution. That is, x is the values in between -2, -1, 0, 1, 2, 3. And corresponding probability value is 0.1 and k 0.2 and 2k 0.3 and 3k. We must find the values of subdivision number A is the k value and subdivision number B is evaluate the probability of x less than 2 and probability of in between the values of -2 and 2. And subdivision number C is find the CDF of x, that is cumulative density distribution function. And subdivision number 4 is evaluate the mean of x. First, we are going to see the value of to find the k value. So we take since summation probability of x is equal to 1 because the total probability value is 1. So the total probability value is 0.1 plus k plus 0.2, 2k plus 3 and 3k is equal to 1. If we adding the left hand side, we will get the values of 6k plus 0.6 is equal to 1 and 6k is equal to 0.4 and k is equal to 1 by 15. This is the value of k. Then next we are going to see substitute this k value in probability of x values. So subdivision number B is probability of x less than 2 is equal to, obviously that is less than x less than 2 means x is equal to -2, -1, 0 or 1. Then we are taking the corresponding probability value, that is probability of x is equal to -2 plus probability of x is equal to 1 plus probability of x is equal to 0 plus probability of x is equal to 1. And corresponding probability value is 1 by 10 plus 1 by 15 plus 1 by 5 plus 2 by, it's a 15. And the final value is equal to 1 by 2. This is the value of subdivision number B. Then corresponding taking probability of x is equal to -1 plus probability of x is equal to 0 plus probability of x is equal to 1. That is 1 by 15 plus 1 by 5 plus 2 by 15, and the value is 2 by 5. Next, we are going to see subdivision number 3, that is cumulative distribution function, that is CDF. The distribution function of x is given by f of x is defined by, that is x is equal to x and probability of x is equal to x, and f of x is equal to p of x less than or equal to x. Here f of x is nothing but it's a cumulative distribution function. So what is the value of x? That is -2, -1, 0, 1, 2, and 3. Similarly, there's a corresponding probability value is 1 by 10, 1 by 15, 2 by 10, 2 by 15, 3 by 10, and 3 by 15. Now we are going to see the cumulative distribution function. That is f of x is equal to probability of x less than or equal to -2. Obviously the value is 1 by 10. And x less than or equal to -1 is equal to 1 by 6. And probability of x less than or 0 is equal to 11 by 30. And x less than or equal to 1 is equal to 1 by 2. And probability of x less than or 2 is equal to 4 by 5. And probability of x less than or equal to 1. Here, total probability value is 1. So we will get the final answer is 1. And subdivision number 4 is find the mean values. So mean of x is defined by expectation of x is equal to summation x into p of x. We already know that the x value is and p corresponding probability values. So expectation of x is equal to -2 into 1 by 10 plus -1 into 1 by 15 and 0 into 1 by 5 plus 1 into 2 by 15 plus 2 into 3 by 10 plus 3 into 1 by 5. Here -2, -1, 0, 1, 2, 3 are x values, and 1 by 10, 1 by 15, 1 by 5, 2 by 15, 3 by 10, and 1 by 5 is corresponding probability values. If we calculate, and we will get the values of 16 by 50, this is the final answer. So next we are going to see problem number 3. The problem number 3 is a random variable x as the following probability function, where x is equal to 0, 1, 2, 3, 4, 5, 6, and 7. And corresponding probability values is 0, k, 2k, 2k, 3k, k square, 2k square, and 7k square plus k. So we must find the subdivisions. The first one is find the k values, and second is evaluate probability of x less than 6 and probability of x greater than 6 and probability of in between 0 to 5. And subdivision number 3 is determine the distribution function of x, and subdivision number 4 is probability of 1.5 less than x less than 4.5 divides x greater than 2. And subdivision number 5 is expectation of 3x minus 4 and variance of 3x minus 4. And subdivision number 6 is the smallest value of n for which probability of x less than or equal to n greater than 1 by 2. So first subdivision number is the find the k values. Since the total probability value is 1, Therefore, we take summation x is equal to 0 to 7. The probability of x is equal to 1. So we must take the probability values. That probability values is here 0k, 2k, 2k, 3k up to 7k squared plus k. So adding the left hand side, we will get the values of 10k square plus 9k minus 1 equal to 0. If simplifying, we will get the values that is k is equal to 1 by 10. If we divide the values is k is equal to 1. So next we are going to see the subdivision number 2, that is probability of x less than 6 is equal to probability of x is equal to 0. Obviously, that is probability of x is equal to 1, 2, 3, 4 and 5. The corresponding probability value is 1 by 10, 2 by 10, 2 by 10 plus 3 by 10 plus 1 by 100 up to. Then the values is, the answer is 81 by 100. So next is probability of x greater than 6. That is total probability value is 1. From subtracting from 1, probability of x less than 6. That is total probability value is 1 and P of x less than 6 values is 81 by 100. Then the values is, the answer is 19 by 100. The next one is probability of 0 to 5. Obviously that is 1, 2, 3 and 4. The corresponding probability values is k plus 2k plus 2k plus 3k. We obviously know that the k values is, that is 1 by 10. 1 by 10. Then the answer is 8 by 10. If divides, we will get the values of 4 by 5. The next subdivision is the distribution of x is given by f of x is equal to probability of x less than x. We know that f of x is nothing but it's a cumulative distribution function. So we take x values and corresponding probability values and f of x values. That x values 0, 1, 2, 3, 4, 5, 6 and 7. The corresponding probability values is 0, 1 by 10, 2 by 10, 2 by 10, 3 by 10, 1 by 100, 2 by 100 and 17 by 100. And corresponding cumulative distribution function is f of x is equal to probability of x less than is equal to 0 and the values is 0. The next one, probability of x less than or equal to 1, the values is 1 by 10. And similarly, probability of x less than or equal to 2 and the values is 3 by 10. And probability of x less than or equal to 3 and the values is 5 by 10. Next, the probability of x less than or equal to 4 and the values is 8 by 10. And probability of x less than or equal to 5 and the values is 81 by 100. And probability of x less than or equal to 6 and the values is 83 by 100. And last one, the values is 1. So here total probability values lies in between 0 to 1. Next, subdivision number 4, that is probability of 1.5 less than x less than 4.5 divides x greater than 2. That is nothing but conditional probability. So in between 1.5 and 4.5, the values are probability of x is equal to 3 plus probability of x is equal to 4. Similarly, the x greater than 2 and the values is total probability value, that is 1 minus probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. And the values is 2 plus 4, that is 5 by 10, and 1 minus 0 plus 1 plus 2, the values is 1 minus 3 by 10. So simplify this and we will get the values of 5 by 7. And next subdivision is expectation of x is equal to summation x into p of x. Here x is the values of x, that is 1, 2, 3, 4, 5, 6 and 7. And p of x is corresponding probability value, that is 1 by 10, 2 by 10, 2 by 10, 3 by 10, 1 by 100, 2 by 100 and 17 by 100. And simplify this, we will get the value that is 3.66. And squaring in terms and is nothing but the squares of x values, that is 1 square, 2 square, 3 square, 4 square, 5 square, 6 and 7. And corresponding probability value, that is 1 by 10, 2 by 10, 2 by 10, 3 by 10, 1 by 100, 2 by 100 and 17 by 100. And simplify this, we will get the values that is 16 by 8. This is expectation of x square value. So next we see the mean value. The mean value is nothing but expectation of x, that is 3.66. And variance formula is expectation of x square minus expectation of x whole square. Here expectation of x square values is 16.8 minus expectation of x whole square values, that is 3.66 square. So simplify this, and the final answer is 3.404. And next subdivision is the smallest value of n for which probability of x less than or equal to n greater than 1 by 2. It's nothing but that is 8 by 10 and the corresponding x value is 4. Here 4 is the answer of the last subdivision. Next, we are going to see the problem number 4, that is the probability mass function of random variable x is defined as probability of x is equal to 0 values is 3c square and probability of x is equal to 1 and the values is 4c minus 10c square and probability of x is equal to 2 is equal to 5c minus 1 where c greater than 0 and probability of x equal to or where r not equal to 0 of 1 comma 2 comma 3. And we must find the values of subdivision number 1, the value of c, and subdivision number 2, that is probability of 0 to 2, it's given x greater than 0, that is conditional probability. And subdivision number 3 is the distribution of function of x. And subdivision number 4, the largest value of x for which f of x less than 1 by 2. So solution. So first subdivision is we must find the c value. So here total probability value is equal to 1. So therefore we take summation of x is equal to 0 to 2 and p of x is equal to 1. And the corresponding probability value is p of 0, p of 1 and p of 2 is equal to 1. And corresponding value, that is 3c square plus 4c minus 10c square plus 5c minus 1 is equal to 1. So simplify this, we will get 7c square minus 9c plus 2 equal to 0. And we will get the values of 1 comma 2 by 7. Here 1 is not applicable, so neglect that. And the values is c is equal to 2 by 7. Here c value is 2 by 7. So the next, the probability distribution is the x values is 0, 1, 2 and corresponding probability value is 12 by 49, 16 by 49 and 21 by 49. So subdivision number 2, that is conditional probability, that is probability of 0 less than 2, it divides x greater than 0. So in between 0 and 2, the values is, so probability of 0 less than x less than 2, so intersection x greater than 0 by probability of x greater than 0. and the values is obviously 0 to 2 and the values is x is equal to 1 and x greater than 0, that is x is equal to 1 and x is equal to 2. So corresponding probability values is 16 by 49 divided by 16 by 49 plus 21 by 49. Simplify this, we will get the value of 16 by 37. This is conditional probability answer. Next, we are going to see the cumulative distribution function, that is CDF. The distribution function of x is, so we already know that x values and f of x values. So x is here 0, 1, 2. The corresponding f of x values is f of 0 is equal to probability of x less than or equal to 0. The values is 12 by 49 and the final answer is 0 by 0.24. And if x is equal to 1, so probability of x less than or equal to 1. So the values of x less than or equal to 1 is nothing but probability of x is equal to 0 plus probability of x is equal to 1. And the corresponding probability value, that is 12 by 49 plus 16 by 49 is equal to 0.57. Similarly, x is equal to 2. The f of 2 is equal to probability of x less than or equal to 2. And the values are p of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. And corresponding probability values is 12 by 49 plus 16 by 49 plus 21 by 49. If we add, we will get the value of 1. So total probability values is 1 and probability values lies in between 0 to 1. And subdivision number 4, the largest value of x for which f of x is equal to probability of x less than or equal to x less than 1 by 2. Obviously, the answer is 0.